All right, welcome to The Explainer. Today we're going to pull back the curtain on the hidden infrastructure of our digital world, those invisible networks that connect and power pretty much everything we do online. Let's dive right in.
Think about it. It's something you do, I don't know, dozens, maybe hundreds of times a day without a second thought. But behind that one simple key press is this incredibly complex and honestly fascinating chain of events. So, how does it actually work?
Well, it all comes down to this kind of invisible world of networks, addresses, and rules. We're about to explore the blueprints, the address books, and even the postal service of the internet, and really show you the magic happening behind your screen.
Okay, so at the very core of it all is this one simple idea, a computer network. The best way to think about it is like a team. Your laptop, your phone, your smart TV, you name it, they're all connected so they can talk to each other and work together. So, just like any team needs a game plan, right? A formation on the field. Well, in the world of networking, we call those topologies. They are the fundamental blueprints that decide how all our devices are connected.
So this topology, it's basically the map. It's the blueprint that tells data exactly how to get from one device to another. And as you're about to see, picking the right map is absolutely critical. If you get it wrong, the whole network can just grind to a halt. So first up, we've got what's called the bus topology. Just imagine a single main street, like a backbone cable. And every single device has its own little driveway connecting right to it. When one device wants to talk, it sends a message out onto that main road. And while every other device sees it, only the one it's addressed to actually listens.
Now, the great thing about the bus topology is just how simple it is. It's cheap, it's easy to set up, but, and this is a huge but, that main cable is a single point of failure. If that cable gets cut or damaged, boom, the entire network goes dark. It's a classic case of simple but, kind of fragile.
Okay, so a much more common design, and one you're probably using right now without even realizing it, is the star topology. Yeah, if you've got a Wi-Fi router at home, that's it. Every device gets its very own private line straight to that central hub.
And right here, you see the classic trade-off. A star network is way more reliable. If your phone's connection drops, my laptop stays online just fine. But it creates a new single point of failure. If that central router goes down, everybody's out.
And our third blueprint is the ring topology. For this one, you can picture devices all connected in a perfect circle, kind of like passing a note around a campfire. Data travels in only one direction, hopping from one device to the next until it finally reaches its destination.
You know, this sort of one-way street design, it's actually fantastic for handling lots of traffic and making sure data packets don't crash into each other. But just like a fragile daisy chain, its biggest weakness is that if one link breaks, just one device or one cable fails, the whole circle's broken, and all communication just stops.
All right, so we've got our blueprints, the physical layouts, but how in the world does your computer use one of these networks to find one specific website among billions? Well, that's where we shift gears from the physical stuff to the, let's call them the logical rules of the road. It's actually a pretty simple three-step dance. First, you type in a familiar website name. Then, this system called DNS acts like a phone book, to look up the site's real number. And finally, a system called IP acts like a mail carrier to deliver your request. Let's dig into each of those.
So, that whole journey kicks off with the URL. That's the nice, human-friendly address we all type into our browsers every day. It doesn't just point to a website, but often to a very specific page or even a file on that site. But really, it's just a nickname. But here's the thing. Computers don't get Google.com. They speak a language of numbers. And this is where the DNS, the domain name system, is the hero. Its one and only job is to be the phone book for the internet. It translates that name you type into the numerical address that a computer can actually understand. And that number that DNS finds, that's the IP address. Think of it as the official, unique street address for every single device connected to the internet. Without it, your data would be like a letter with no address on the envelope. The Postal Service would have no clue where to send.
Now, you might have heard people talk about different IP versions. The original one, IPv4, was kind of like a phone numbering system that's just, well, it's running out of numbers. So the whole world is shifting over to IPv6, which gives us a number of addresses that is just, it's astronomical. I mean, enough for literally every grain of sand on Earth with plenty left over.
Okay, so we have our physical blueprints, the topologies, and we have our digital address book, the whole DNS and IP system. Let's put them side by side now and see why you'd pick one design over another. It's all about choosing the right tool for the job.
When you lay out our network blueprints like this, the trade-offs really pop. The bus? Super simple, but also super fragile. Star is way more reliable, but that central hub is its Achilles heel. And the ring keeps things orderly, but just one break in the chain and the whole thing is down. See? Every design is a solution for a specific problem.
And it's not just about the blueprint. Networks are also defined by how big they are physically. You've got your LAN, your local area network. That's small, like your house. Since the wires don't have far to go, it's blazing fast and cheap. But as you scale up to a WAN, a wide area network, connecting whole cities or the entire globe, well, all that distance and complexity naturally slows things down and costs a whole lot more. And MANs? They're just the happy medium in between.
Okay, so let's tie this all together. How do these kind of abstract ideas, topologies, addresses, network types, how do they actually play out in your everyday life, from your home all the way out to the world?
Well, that Wi-Fi you're using at home, that's a LAN. And it's almost certainly a star topology, with your router sitting right there in the middle. Every single time you go to a website, you're relying on DNS and IP addresses. And the moment you connect to anything outside your own house, you're tapping into the biggest WAN of them all, the internet itself. It's all connected.
So these are the fundamental principles that our entire connected world is built on. But, as we keep adding billions more devices, and we all want faster and faster speeds, it really leaves us with a pretty cool question to think about. What will the network of the future even look like? What new blueprints and rules are we going to need for tomorrow? Thanks for joining us on The Explainer.